Hello class, and welcome to an introduction on related rates. Today we're going to talk about just how to find a related rate and what is it. So take a look at this diagram, and what we're going to try to do is imagine that we have a ladder against the side of a house. So each of these red lines represents the ladder, and that ladder is sliding down the side of the house, and therefore the bottom is sliding out. And what we'll notice is that each time we take a look at this, as it's sliding out there is a different x value, a different y value, but the same length of the ladder, at least it should be, okay? So we have a fixed length on a ladder that's sliding out. We know that each of these diagrams has Pythagorean theorem, that x squared plus y squared equals d squared. We'll make the assumption that the house was directly vertical from the ground that was out from it. It's a bit of a stretch, but we'll assume that. So we know we have x squared plus y squared equals d squared. What a related rate is the easy way to talk about this is just to say, if I'm going to relate the rates, all I'm going to do is I'm going to do implicit differentiation for each of the variables, okay? So that this is going to be 2 times x, and then I need to multiply that by implicit differentiation dx dt. So what is the rate of the x's with respect to time? So I've introduced a new variable of time that's not one of the variables in my equation, and that's what makes it a rate. And that will equal 2y dy dt, the rate at which the y values are changing, and that should equal 2d dd dt. Now, those things are connected. However, in my problem over here, where I have this falling down here, the d is going to be constant. Okay, so the distance there would always be constant, and therefore this would have changed to an idea that we have x squared plus y squared equals, say, 15 squared for my distance. And when I take that derivative, 15 squared is 225, and its derivative is going to turn out to be 0. So in this instance, I don't know if I can erase that. I might just need to right over it. In this instance, that side will be 0 for the ladder sliding down. Before we go on with that example, let's look at another one. Another idea, we could say that the area of any circle is pi times its radius squared. And I might want to know, how is the rate of the area changing with respect to the rate of the radius changing? And so to do that, we simply go down here and we take the derivative. So the derivative of the area with respect to time will equal 2 times pi, remember pi is a constant, times r, and then dr dt. And so now I have done another derivative here. Now, so I have the formula for it, but then it depends on what question they ask is what we'll plug in and what we'll try to figure out. Let's go up here and do the ladder sliding down here. Imagine that we take a look at this when the x value is 10. So we're going to have this over here. We're at the instant where the distance there is 10 units away from there, from the base of the house. Okay? And note, if I know that dx dt is increasing at a rate of 2 feet per second. So those two things we know, that the rate that it's increased, that dx dt is increasing at 2 feet per second at that instant, the x value is 10. Can you figure out how fast this is falling down? The ladder, the top of the ladder is falling down the side of the house at that instant in time. So what we're looking at is right here, how fast is it falling down? And what we can do then is simply plug this back in to the equation that we had. So we have 2 times the x value, which we now know is 10, times the rate, which we know is 2 in feet per second, and we add that to 2 times the y value. And dy dt. Well, we have some things that we don't know, and that should all be equal to 0. We don't know y or dy dt. However, because it's Pythagorean theorem, and it's x squared plus y squared is 15 squared, and we know that x is 10, we can figure this out. We can see that 10 squared plus y squared should equal 15 squared, because it's at that instant. So therefore, at that instant, y squared is 225 minus 100, which is 125. So y will be 5 times the square root of 5. So we're going to multiply this by 5 square roots of 5, but we don't know dy dt. And as you can see, there's only one thing we have left that we don't know. And so we can solve for that dy dt and see that the rate that it's falling will be equal to 20 times 2 is 40, so that's going to be negative 40 divided by 10 times the square root of 5. okay? And the units will be the same units as we had over here in feet per second, okay? So that would be the rate that's following. Notice it's negative, and that makes sense with our situation because as the x is increasing, the y value is decreasing. So there is an introduction into related rates. The interesting part for all of these problems is you need to figure out first the equation, which that's the hard part, is to figure out what equation it is and how things are changing and if anything is constant, and then to plug things in and what things do I know. Like we knew that the x value, so that we also knew the y value, and they didn't tell us that explicitly in the directions. Good luck on these problems, and feel free to use the internet for other helps and to see how things go, and I'm sure you're going to be looking them up, and hopefully you can understand this idea of just use implicit differentiation to find a rate, and then we'll plug things in to solve whatever question that they're asking. Good luck, and hopefully I'll see you guys on Thursday.